Okay, welcome back to section 2.6, skewness and the mean, median, and mode. This is a very short section, so let's consider the following data set. Okay, here you have this data, and let's represent it using a histogram, and here it is. So if you notice, this histogram is symmetrical. What does that mean, symmetrical? Well, can you imagine a vertical line, a line going up and down, that's basically cutting the histogram exactly in half? Okay, so where one side is exactly the same as the other, or mirror image of each other. Okay, so imagine I can draw a line here and fold it on itself, and it perfectly matches. That's what you would consider symmetrical. Okay, so in this case, the mean and the median and the mode are all 7. Okay, so when you have something that's perfectly symmetrical, the mean and the median are the same. Now this example has one mode, and so it's considered unimodal, and that mode is the same as the mean and the median. Now if you have a symmetrical distribution with two modes, bimodal, then that would be different from the mean and the median. Okay, so here's an example of that. So here we have our symmetrical distribution with one mode, but look at this example here. Okay, so this data set has, if you notice, and has the same amount of 7s as it does 8s. So you have 6 7s and 6 8s. So this is a bimodal distribution, right? Because you have two modes, and it would look something like this. All right, let's consider another histogram. So let's say this data right here, where your mode is 7, okay, and you have 4 5 3 6s, 4 7s, and an 8. It looks like as if the right hand is kind of chopped off. It's not symmetrical, right? And it has this kind of like a tail to the left. So we would call this skewed to the left, a distribution. Like we would categorize this as skewed to the left because it has that little tail. Now, listen carefully. So here the mean is 6.3 and the median is 6.5 and the mode is 7. So the mean is less than the median. Okay, so it's kind of going towards the left. So you can kind of think like, well, the mean reflects the skewing. If mean is less than the median and less than the mode, then skewed to the left. Okay. What about the other way? So let's consider this set of data. You have a histogram here with there's 4 7s, and now it has a little bit of a tail to the right. Okay, it's not symmetrical. So we would say this is skewed to the right. Now in this case, and you can check this for yourself, the mean is 7.7 and the median is 7.5, and the mode is 7. Okay, so out of all of these, the mean is to the right, or the largest. Okay, so when the mean is the largest, the mode is the smallest. So again, the mean reflects the skewing because the mean is greater than the median. Okay, so basically in general, if the data is skewed to the left, mean is less than the median, which is often less than the mode. And if it's skewed to the right, mode is less than the median, or you can think of it, which is less than the mean, or you can think of it as the mean is greater than the median, which is often greater than the mode. Okay, and that's it for 2.6, and I will see you guys on the next video. Have